meeting, but generally we eat cake and we sing, and people can get dressed up if you want, bring some kids if you want. And we have like a raffle parties. You get a ticket when you come in, and they drawings, and there'll be lots of stuff, and it's a good time. So I encourage you all. It's not a dinner. The dinner is in February for the banquet. This is going to be just dessert thing and party kind of, and a little bit of slides, not a whole lot. Anyway, I'd encourage you all to come. So let's get on with it. I'd like to see if there are any new hams and new club members tonight. I know there are, so please raise your hand and tell us your call and a little bit about
My name is Mark. My call is KC7IKV. I just recently moved to Battleground, retired about 1.5 years ago. And so now I have a little time for ham radio. So, yeah.
And Patty is the one sitting next to him. I'm sure we'll be happy to see her around as well.
No, I'm not new. This is my second time here.
Second time.
Robin Holm, KK7 MVL, or I like to say motor vehicle license because then I remember it. What am I supposed to say? That's good enough. All right.
That's good. Thank you. Welcome.
Hi, everyone. My name is Dallin. I'm just a baby fresh ham. Just had my license for a few weeks now. All signed KK7WAE. I'm excited to be here.
That's easy to remember. It's worked all Europe.
Future DXer.
Hi, I'm Mark, and I'm studying for my technicians, so I don't have a call sign yet, but I hope so soon. So I just moved here.
Well, keep it up. Look forward to having you.
My name is Paul. I am pretty new to the hobby too. Call sign is KK7VBO. And this is my second meeting here. I'm glad to be here.
Thank you for coming. Glad you're here.
My name is Doug. Call sign is KE6MRM. Moved up to Ridgefield about 4 years ago.
Welcome.
Norman, KK7EOJ. 2 years ago, I got my technician's license, but
We look forward to hearing you on the air sometime.
Okay, Dave, I think that's it.
Okay. Well, welcome to all of you, and we encourage you to check out the club website and see all that. There's a lot of stuff going on. If you want to help with something or get some information or have somebody help you learn how to program your radio or put up an antenna, there's a lot of resources. So take advantage of them. Take advantage of them. So now, are there any license upgrades? Anybody get an upgrade here recently? Well, yeah. From non-tech to tech, is that the, oh, general, you made general. Well, congratulations. So are you on HF yet? Okay. Well, there's plenty of help, like I said. Okay. Now, has anybody gotten some kind of award or certificate or anything they're proud of that they'd like to share? Anybody get a worked all states or a DXCC or win a contest or anything? Okay, I guess not. I guess not. Okay, so let's move on here. Run through a few general announcements before the program. Quick reminder, Veterans Day Parade is this coming Monday, and those of you involved should know, should have had all the information. If you have any questions, contact me and we'll get the information to you if you don't understand something. But we'll talk about this more a little bit later in the program too. Secondly, there is a VE test session for those of you looking to upgrade, November 16th. So that's coming up next weekend. And it's at the usual place, 49th Street, LDS Chapel. The map and the info are on the club website. So just go to the club website and under VEs, you'll see it under the VE session. And there's a map. You can click it. It'll give you directions, everything. So, and we have, especially for those of you that are new, we have surplus equipment sales. We have a couple of storage units full of goodies, and Dave Churba kind of runs that, and you can look on the website and see that too, or if you get the newsletter, I think there's a link in there.
I am going to have a Black Friday sale this year too. And I will be paying people to take stuff. No, you will make a minimum bid to get some stuff. So we're going to have a Black Friday sale. So watch the website and the link to the PDF for that good stuff.
There's a lot of good stuff there, and there's a lot of different stuff there. So it's like anything, it's in the eye of the beholder, you know, so. And now a reminder about membership renewal. There's a gift card drawing at the annual banquet, and if you renew by tonight, you get 2 entries. So you can go right over there and see Wayne and Judith, and they'll take your dues and sign you in. And if you renew between tomorrow and December 15th, you get 1 entry in the an additional entry in that. So you end up with more entries in the annual banquet drawing, and they're for gift cards. So it's a pretty good deal. And speaking of membership, if you're a new member and you renew now between now and the end of the year, I believe.
It's the December 22nd or thereabouts.
December 22nd. Okay, then that counts for next year's membership too. So that's a deal. You get a little bit of extra time. So. And our January meeting is a business meeting. We are a state licensed, I guess, nonprofit, and we have to follow some rules. So we have a business meeting once a year, and we certify the election results. We're having an election coming up, and for some new directors and a VP, and your membership has to be current before you can vote for the vote to count. So, you know, renew now, in other words, if you can. Okay, and I have one other announcement that just came up. One of our members, Rick Aragon, is in the hospital for a few days. He's been having issues, and he appears to be okay. He's down in Sunnyside. If you want some more information, Delvin Button is here. He has a room number and he knows how to go see him. And we will be sending him a get well card from the club. So, but I heard that he's seems to be okay. He's going to be there at least a couple days, but they're checking him out. Okay. So now we're at the presentation, and go ahead, Dave.
All right. John Pontoon has a whole slew of presentations on the web. He did our meeting here a couple of months ago about the slot antennas, and I've asked him to talk tonight about balance and ferrites. I have a vested interest. I'm about to put up a 40-meter loop, a delta loop, and I need to build a balun for it. So I'm hoping he'll have the magic answers tonight. John, go ahead and let me make sure you can share your screen, and then we'll get you started. Okay, John, you should be able to go ahead and share your screen now and take it away. We're not hearing any audio, John.
Sorry about that. You got audio now?
Yes, we are good audio now. Thank you very much.
Okay, good. Sorry about that. I needed to click the button. Very good. Well, thank you for having me back. I've enjoyed this type of thing. Okay. All right, we're sharing the screen here. So let's go to the presentation. And there it is, and get to the slideshow part of this. get this out of the way. Too many things on a laptop. From the beginning. Okay, I'm going to turn this down now. Okay, you should now be seeing the opening title slide of the presentation. Is that right? Are you seeing it?
Yes, it's looking good.
Okay, good. Very well. Well, this is a topic that kind of troubled me for a long time on how to take ferrite toroids, which are pretty common, and turn them into ballads. And I would read almost any technical book that would come out and see if I could figure out what was going on. Always found it difficult. Ultimately, I found out it is not difficult. And by the way, these slides, or any of the slides I use in my presentations, are always available for download. And what you're seeing tonight, you don't have to write anything down. The only thing you need to write down is what you see here below our friend here for the dummy, our dummies book mascot there is w6nbc.com/slides. And if you go there, you will be able to download the slides from this presentation. In fact, all the presentations that I give to various club lectures, if you want to look at them. They're the full PowerPoint slides. If you are interested in it, just go there and look for ferrite, look for toroids, and you'll find this particular presentation. Frankly, most hams don't have a clue on how to build a ferrite toroid ballot. Toroids are kind of a mystery to hams, and not surprising. That doesn't surprise me. They might physically know how to build that thing you see in the upper left-hand corner, but like Sherlock down there on the right, lower right, how to actually wind the windings on that toroid and what kind of a toroid to select to do the job is pretty much of a mystery to most hams. And to wind a 1-to-1 or a 4-to-1 or maybe a 7-to-1 ballot. By the way, this ratio of 7-to-1 is also sometimes quoted as 49-to-1. Why do we have the two ratings? Well, it's pretty simple. A 7-to-1 ballot is the turns ratio, the ratio of 1 turn to 7 turns. But the impedance ratio that it matches is 49-to-1. In other words, a 7-to-1 matches a 49-to-1 impedance ratio. And a 4-to-1 ballot matches a 16-to-1 impedance ratio. So you may hear of toroids being mentioned either as 7-to-1s or 49-to-1s, or a 44-to-1 being mentioned as a 16-to-1 ballot. That's not a problem. So let's look at how to build one of those things up there, not so much how to put it in the box. I think most of you can figure out how to do that. That's a typical waterproof conduit box up there, and I think most of you know what that stainless hardware is and how to get that, including the SO239 connector. And the wire that's on the toroid is not a particular mystery. But how many turns? And that's the point that we're looking at here today. So many hams, like this very erudite young gentleman here. My wife found this picture a few years ago, and I like to use it in my lectures. The book this young fellow's reading did not say ferrites on the front of it, so I just put that on with Photoshop. But so many hams like me would go to the handbooks to try to figure out how to make a toroid, to make a ballot. And I always got confused when I did that. And I've read many of them, and always what I do when I'd get a new handbook is to dig into it and see what it had to say about ferrites and toroids. And it seemed like I was always confused because there is a great deal of irrelevant information. Irrelevant as far as the practical ham is concerned. It's not wrong information. It's just more than you need. And here you see a picture of my bookshelf. It's about 6 feet away from me from where I'm sitting right now. And you'll see all sorts of the Bibles of ham radio on there. Radio handbooks, ARRL handbooks, and various other of the major handbooks like Terman and Jansky and others of the radio handbooks that some of you may have. And you go looking in those handbooks on how to wind toroids and you'll get overwhelmed. And I was overwhelmed when I used to try to read these handbooks. They talk about powdered iron and ferrite and permeability and saturation. And all those things are true, but you don't really need all of that stuff. That's pretty much irrelevant as far as practical designing of toroids to make balance. It's really much simpler than that. That's why this presentation is Ferrite Toroids for Dummies. It's not a mystery as long as you understand the primary job of a ballon. And by the way, I don't like the term ballon. It's a misleading term. It's not a wrong term. It just doesn't tell you what a ballon does. And that's what I would like to talk about tonight here, about what a ballon does. It'll help you to understand how to wind a toroid and why you wind and why you need one. Ballons, as they are often called, which is a portmanteau of two words, balanced and unbalanced. Yes, they do that, but that's not their primary job, is balanced and unbalanced. That's kind of a misnomer as far as I'm concerned. I call them something else, and we'll get to that here in a minute. But they are the consequence of skin effect. Skin effect is what makes us need them. Now here's a piece of wire. I show it gray here because it might be an aluminum wire, because most rigid antennas are made out of aluminum, although wire antennas might be made out of copper. It doesn't matter what the wire is made out of. But if you try to put alternating current, particularly RF current, which is high frequency alternating current, down a piece of wire, it does not flow uniformly through that conductor like DC current does. Put DC current down a wire, the current density through the wire is pretty uniform from center or the outside or the inside. But that's not true of alternating current. Particularly, it's not true of RF current, because the RF current flowing through the wire creates a magnetic field and it drives all of the current to the edge and to the outside. And in a round wire, it forms a skin on the outside of it. Hence, we use the term skin effect. So in this piece of wire, if the RF flowing on or in this piece of wire is all flowing on the surface, there's none of it flowing in the middle of the wire. In fact, that can be used to your advantage. For example, I like to make magnetic loops, for example. I don't make them out of solid copper pipe or solid aluminum pipe. It's a waste of money and a waste of time. I like to use plastic PVC pipe and put aluminum foil on the surface of the pipe. Works just as well as solid metal pipe because all the current's flowing on the surface. It doesn't care what's on the inside of the pipe. Magnetic loops don't need to be made out of solid copper pipe. It's a surprise to most hams to learn. Here's a piece of coax cut in half, and you're looking at the end of the cut set. Cut a piece of coax in half and look at the end. Skin effect causes coax to have 3 conductors, not 2, but 3. I know you'll say, well, if I cut a piece of coax in half, I only see 2 conductors, the center conductor and the shield. Well, yes, physically, and for direct current, that's correct, just 2 conductors, but not for RF. For RF, there are 3 conductors in coax. Skin effect separates the shield into 2 separate conductors. They're completely separate, by the way, as far as the RF is concerned. Current can flow on the outside and the inside simultaneously in different directions, in different phase, and in different amplitude. So coax has 3 conductors, and this is a very important principle for hams to understand. And there's a space between these two conductors, the outside shield and the inside of the shield. It's like there were 2 physical metal shells separated by an insulator. There isn't an insulator between them, but there's no conduction going on between them. And so it's important for you to recognize that there are 2 separate conductors in the shield. the skin on the inside and the skin on the outside. Now, the center conductor would do the same thing, except that we never bother ourselves with the inside of the center conductor. So the conduction in a piece of coax is on the outside of the center conductor, the skin on the outside of the center conductor, and the skin on the inside of the center conductor. That's the balanced part of coax. But because we've got a third conductor on the outside caused by skin effect, coax is unbalanced. And it's getting rid of that outside conductor that the balun is a balun. It gets rid of the unbalanced outside skin of the conductor and limits all of the action just to the blue and the red, the skin on the inside of the shield and the skin on the outside of the center conductor. 3 conductors for coax as far as the RF is concerned. Now, this is a little FYI slide here, which I've added from another presentation, which I also give, but you might find it interesting. Low loss coax. And this is, we've just moved off the topic here for just a moment. I want to tell you this one because I found this one kind of interesting. In fact, in the September issue of QST, there's a complete article on this particular point, but I thought I'd show it to you. Low loss coax. Where is the main source of loss in coax? It's on the center conductor. The small center conductor has much less surface area on it than the inside of the shield, which is the other conductor, and it's the resistive loss on the surface of the center conductor where the main loss takes place. And so low loss coax, like LMR 400 that you see at the bottom, the reason it's low loss coax is because the center conductor is bigger. Notice how much bigger it is. There's a much tighter ratio between the size of the shield and the size of the center conductor in low loss coax. And this is done by using foam dielectric. So most low loss coax has foam dielectric and a much bigger center conductor compared to the shield. And that's why low loss coax it has low loss, because of that bigger center conductor. Cut a piece of LMR at 400 in half and you'll see how much bigger the center conductor is. In fact, here's a picture of it. Here's a piece of RG8 on the right. This is a piece of RG8 I had on my workbench. I just cut it in half and you can see the shield and the center conductor. You see its size. I just took a piece of LMR 400, which has foam dielectric, and the solid dielectric RG8, and cut them in half, and you can see the different diameter ratio. Why does it have foam dielectric? That's because the ratio to keep the coax 50 ohms, we have to have a lower dielectric constant. That's why the dielectric is foamed, to give you a lower dielectric constant to keep this coax at 50 ohms characteristic impedance. So the reason low loss coax is foamed is so it can have a bigger center conductor. And that's why it works that way. That's an extra. You didn't have to see that, but I thought you might find it interesting. Okay, back to the topic. Here's the coax now. Here's the coax sliced instead of in half looking at the end. Here's it sliced lengthwise. And you see the 3 conductors. The center conductor, the RF flows on the surface, and the shield, which divides itself into 2 separate conductors. They're completely separate. RF can flow on the 2 of them independently, different magnitudes, different phases, in fact, different frequencies, in fact. Frequencies can flow on the shield that aren't flowing on the inside from other sources. Here's what happens. From the transmitter, which is on the left, not shown here, signal comes up on the outside of the center conductor and on the inside of the shield. Comes up, to the end where it gets connected to the antenna. And I'm showing a vertical dipole here in this particular case, goes out to the dipole, does its job, bounces off the end and comes back, and then rejoins the coax to go back to the transmitter to complete the circuit. But what happens? It meets the end of the coax, where skin effect connects the inside and the outside of the shield together by skin effect. The skin effect runs around the end and shorts the inside of the shield to the outside of the field. This happens any place coax ends, whether it be at the end of the coax or at a balun connector in the middle of the coax. It happens any place coax ends. You've got this short circuit between the shield and the center conductor and the inside of the shield. What is the balun for? The balun is to choke off any current that gets coming back from the dipole that will have a tendency to run down the shield, outside of the shield, just as much as it wants to run down the inside of the shield as well. It has two paths it can take when it comes back off the dipole. You're not going to blame it for running down both of them if it's available. The balun is put there as a choke to get rid of the path that's down the outside of the shield, which is a completely independent and separate conductor from the inside of the shield. That's the purpose of the balun. That we want to put a blockage. We want to put a blockage. I got to move this out of the way. And I still can't see it. You want to put a blockage here in the way of the path that exists because of this short circuit at the end, so that the current cannot flow back down the outside of the shield and the inside of the shield. And it wants to have a minimum of 200 ohms resistance, AC resistance, or reactance, as the proper term is. That's the purpose of the balun, to be a blockage or a shield current choke. That's what I like to call balance. I don't like to call them balance. Yes, it gets rid of the unbalanced ballast situation by getting rid of the shield and turns coax back into balanced line. But I like to call them shield current chokes, because that's what they really are. That's what they do. That's their function in life. So I don't like to think of that. I don't like that term balun. I wish it had never been created. It's like adding a third wire to a perfectly balanced antenna. Now here's a perfectly balanced antenna, just a nice wire dipole made out of some yellow wire there, and it's being fed by a nice balanced transmission line, some 450 ohm slotted transmission line. What would you think would happen if you'd go up to this nice balanced antenna fed by nice balanced transmission line and just take a piece of random wire and hook it to one side of that antenna? Do you think it would mess things up? Do you think it would disrupt the SWR? It would disrupt the tuning? Do you think it would disrupt the radiation pattern of this antenna? I think most of you would agree it certainly would do all of those three things. It might change any of them. Well, that's exactly what the shield does if you don't put that choke up there at the antenna to get rid of that third conductor that's always there at the end of every end of a coax. But here's the real biggie. The real biggie. What about down at your shack? Notice that down at your shack, the same short circuit and the same two conductors on the coax exist down there too, not just up at your antenna. They also exist back at the shield, back at the shack. Now here we show a transistor inside of a dotted box. That's a symbol of your transmitter. It might not be a bipolar transistor like I'm showing you there. It could be a field effect transistor or even a vacuum tube. But the coax still ends there. And when this transistor tries to put the energy where it wants to go onto the outside of the center conductor or the inside of the shield, it's also got that outside path. It's there at the other end of the coax too. Therefore, you need to choke that end off too. You need balance at both ends of your coax, not just at the antenna. It's an old myth that all of you need to get out of your thinking, that if you've got a balun up at your antenna, you won't have common mode current back in your shack. That's not true. You may have common mode current back in your shack if you don't also have a balun down at your transmitter, because you need it at both ends. The short circuit exists at both ends. You need a shield choke or a balun also at the shack on all coaxes. So I've got them on all coaxes, not just up at the antenna. I learned this by hard lesson. The primary job of all baluns is to choke off the outside shield current. The secondary job is to be an impedance transformer. But it's always an outside coax shield current choke. Now, so enough said about that, but I think it's quite an eye-opener to realize that you need to choke off and get rid of that short circuit at the end of coax back at your shack, just as much as you need to get rid of it up at the antenna as well. You don't need to get rid of it at barrel connectors or switches, because there's no source of RF energy there to get onto the line at those points. But at your transmitter or up at your antenna where there's a source of RF energy to get onto the shield, you got to choke it off with chokes. Anyway, and remember, you can get all of this information from w6nbc.com/slides. Now you need to get yourself a calculator. You can get this little calculator. It's a free online calculator. It's called Coil 32, and you get it at this and it has available there the Amadon ferrite toroid calculator. And this is what we're going to use to build the toroids with. So you want to go out and get that calculator. And here's what it looks like. You get this little calculator and it looks just like this. It gives you a place to put in 3 different things. The material of the toroid, that's the mix of the toroid. The size of the toroid, they come in different sizes, from tiny little toroids up to big toroids. That depends on the amount of power you're running. And also the amount of inductance that you want to have on the toroid to do the amount of choking that you need, which is 200 ohms. That's the minimum amount of choking you need to get rid of the shield current. It's 4 times the system impedance. That's considered to be the minimum amount of choking that you need to get rid of the shield current, the common mode current, as it's commonly choked. This little calculator, which is an excellent little calculator, readily available, is all you need to wind toroids. And it has in it all of the different kinds of toroids, the different materials, the different mixes, all of the different dimensions, the sizes of the toroids. And all you need to know is the amount of inductance. And I'll show you how to get that too here in a minute. Once you get them, you put in these 3 numbers. We're going to show you an example of doing that. And then push the little calculate button right here, this little calculate button. And when you do it, it'll tell you the number of turns to wind on the toroid. Easy peasy, no problem whatsoever. You've got the toroid, which this calculator will tell you what to get, and you've got the toroid. You don't have to look in the books. You don't have to get confused at all. By the way, it's also exactly the same process that you use to wind an ugly balun. An ugly balun is not to use ferrite, but to use a wind of coax. Many of you may use ugly baluns. And you see one of them here on the right. And there's another little calculator which you might want to get, which you get here at this URL here. And again, remember, you can get it just by downloading the slides, so you don't need to write all of that stuff down. The same process that I'm showing you here for toroids works very well for ugly baluns as well. Okay, how do we do it now? Okay, First of all, we need to pick a toroid. Toroids are picked by two things. The frequency, that's determined by the mix. That's how much of the magnetic particles are fired into the ceramic. Toroids are a ceramic, just like clay pots, just like ceramic figurines you might have. They're fired clay. They're fired in a kiln, but in them is embedded magnetic particles of different types, different either ferrite or powdered iron. But you don't need to bother yourself by the kind of material. It's just the mix number that you need to know, and I'll give you some guidance on that. And then you need to know the size of the toroid, and that's determined by how much power you're running. We'll get to this in a minute. Then you need to find the inductance that you need to give you the amount of choking that you need to choke off that shield current, not let it get back on the coax at your antenna, or not let your transmitter put it on the coax at the transmitter end. It needs to have an AC resistance of 200 ohms. You need to find that inductance to get to at the frequency. It's a fairly simple little formula to calculate it, but you need to do that. Then once you have this information, you use the calculator and push the button, and it'll give you the number of turns. It's very, very simple. So step number one, let's pick a toroid by frequency and power. Okay, this shows you, by the way, this is a table. You don't need to have this table. I'm just showing it to you for interest's sake, showing you all the different mixes of ferrite. This is how much magnetic material is fired into the ceramic when the toroids are fired in a kiln and made as they're a glassy-like thing, just like a teacup. They're like the ceramic in a teacup, but they have magnetic particles fired in them to make them magnetic. And this shows you their permeability, how magnetic they are. You can see they vary in their magnetic property, which is called permeability, with the Greek letter mu as the symbol for it, from mix 68 to mix 76. That you can see they vary over a very wide range of permeability, and you can buy toroids in all these different mixes. But you really, for ham radio use, you really only need to be concerned by 4 mixes. Really only 3 mixes. In fact, you might, on the extreme, use 5 mixes, but the 3 marked in blue are the ones you probably want to concern yourself. I wouldn't worry about any other mixes. If you want to work at VHF and UHF, 440 and 2 meters and 220, you want to pick a toroid that's mix 61. Mix 61 is what you want to pick for the toroid. If you want to work at HF, there are 2 mixes that work very satisfactorily: mix 43 and mix 31. Now I know a lot of hams absolutely swear by mix 31. They say it's the only one to use. That's kind of a myth. Mix 43 works just as well for HF as well. It just needs a few more turns. That's all. And it'll do the same job as mix 31. So don't let the local know-it-all tell you got to use mix 31. Mix 43 works fine. I only use mix 43. Why? Because it's cheaper. You can often buy mix 43 toroids surplus, where you can rarely buy mix 31 toroids. But if you want to use 31 because you think that's the hot ticket, go ahead. Either mix 43 or mix 31. Those are the only mixes you need to really know. 73, if you want to build RF transformers, and mix 67 up at the other end would be rarely used if you want to really get high up into frequency. But I never consider myself, I never get at these extremes. Mix 61, mix 43 are my two choices for the mixes of toroids. Now, this chart, as you can see it over there on the left, comes from a very nice little paper that you also might want to get for yourself. It's written by another fellow who does a lot of lecturing. His name is Karl Leuchel-Schwab. Since I speak pretty good German, I can pronounce his name. Leuchel-Schwab. It doesn't mean anything in German. It's just a name, K9LA. He often speaks at conventions. But he wrote a very interesting little article, which is you might want to get a copy of it. In fact, that's where I got that diagram that I just showed you. You can see it there on the left. It's an article on how to identify unknown ferrite cores. If you've got an MFJ 259B or a similar analyzer, or you've got a nano VNA, you can take an unknown toroid, throw a one-turn winding on it, and work backwards and find out what mix you've got. And this is quite handy if you're out at a swap meet someday and you see some nice toroids there, and you think, well, maybe I could make a balun out of one of those. Well, with this little article, it'll tell you exactly whether you can use it or not. Highly recommend you get that article. Okay, how about power? It's very simply a matter of size. The 2.4 inch, let me move this over. The 2.4 inch toroids, which by the way, is always in the mix, is always in the part number. Toroids, this is the common part number for toroids. FT for ferrite toroid. 240 means it's a 2.4 inch toroid. You see, 2.4 inches in outside diameter. And the 43 is the mix. So if you go to a company to buy a toroid, it'll usually be FT 240 for the size, 43 for the mix. If it would be a 2.4 inch mix 31, it would be an FT 240-31 or 63, whichever mix you choose. So that's how you pick it. A 240 or a 2.4 inch toroid is good for full legal limit. If you want to be belt and suspenders, just make a stack of 2 of them, and then you can handle more power. If it gets too warm for you, if they heat up too much, if you've got a little IR meter that shows you, or a little infrared camera that you can see the heating, and your balun heats up a little too much for you, just make a stack of 2 of these toroids on top of each other, but wind the same number of turns on it, and it'll work just fine. It'll handle twice the power, or at least a good bit more power. The 1.4 inch toroids, and all of these numbers come in that calculator, by the way. A 1.4 inch toroid is good for 100 watts. And again, if you wanted to double it up for 200 watts, that would be fine. So you only need 2 sizes of toroids, 2.4 inches, which is the 240s, or 1.4 inch toroids, which are the FT 140s, and then the mix, and you've got the toroid that you need to do the job for the power you want to run. Easy to pick the toroid. Now that we've got the toroid that we want to use to make the balun. And by the way, Ferrite Company. The Ferrite Company is a major manufacturer of toroids. They're located, I forget, somewhere on the east coast of the US. They do retail sales. You can go to their website, ferrite.com, and buy them in onesie twosies. That's what I do. And the onesie twosie price on the Ferrite internet sales for an FT 140, this is 100 watt 1.4 inch mix 43 HF toroid is $7.35, and they'll mail it to you. They'll ship it to you directly from Ferrite, so you don't have to go scrounging around to find these. Just order them directly from Ferrite. I get all of my toroids directly from Ferrite. Although you can buy them from some ham dealers as well. All right, let's build a toroid. This is the little calculator. You go in there and you press on this little arrow here, and it'll have all the different mixes in there, every one of them. And so I've picked mix 43 here because I want to build a 100 watt balun for 100 watts, mix 43. And so I'm going to then go down to this little box, and I'm going to pull the arrow down, and it'll give you all the different sizes of the toroid. So I'm going to pick a 1.4. It goes all the way down to the little tiny ones and all the way up to the really big ones. So I'm going to pick a 1.4, and that's what I did here. Now, all of this information down here is fine if you want it, but it's just supplementary information. It'll give you the dimensions of the toroids and a bunch of other technical information if you'd like to have it, but you don't really need any of this on any of this data. Then the other piece of information you need here is the amount of inductance that you need on that. And that's determined by the amount of turns you have to put on the toroid to give you 200 ohms of choking impedance on that toroid to block that shield current. Once you know how much inductance to put on there, you just put that in there, and that's an easy to figure out with a simple little equation. Push the button and it'll tell you the number of turns to white. Couldn't be easier. So step number 2, find the inductance for minimum choking. Here it is. We want an RF resistance of 200 ohms minimum. That's 4 times the coax impedance, or the system impedance of 50 ohms. Well, most all transmitters, including most ham transmitters, are 50 ohm systems. We know that. We run 50 ohm coax. And so by placing a choking impedance of 200 ohms right where the power can leak out onto the outside of the shield, if we put a choke of 400 ohms impedance, we'll pretty much get rid of all the bad effects. Now, the simple formula is the amount of inductance in reactance is X sub L. That's the 200 ohms. That's the 200 ohms is the RF resistance, equals 2 pi times the frequency times the inductance in henries. It's a basic formula which you'll find in any radio books. If you break it down, it's really much simpler if you kind of work the equation. So the inductance this is the same equation, just manipulated with a little algebra. So the inductance in microhenries, if we work in megahertz, so microhenries and megahertz will cancel each other out. So if we want to get the inductance that we need in microhenries, we put in the 200 ohms that we want, and it's divided by 6.28 and multiply it times the 6.28 multiply it times the frequency. So it's a simple little formula, simple little equation that almost anybody with the slightest amount of algebra can work it out. And I'm sure even if you can't work that equation, I'm sure one of your buddies can work it for you. But in case you can't work that simplest of math, here's a table. You can just look it up on the table. This will show you this little table is just that equation worked out for you for all the bands 160 meters through 10 meters down here, showing you, for example, that at 1.8 megahertz, which is the bottom of 160 meters, you need 17.7 microhenries to give you 200 ohms of choking impedance. 28 megahertz, 10 meters, you're going to need 1.1 microhenries, much less. This is the third number we need in the little calculator. We know the size, we've already put that in. We know the mix, we've already put that in. And now this is the third piece, and it'll tell us exactly what to do, how many turns to put on our toroid. So here we are. We're now going to make ourselves a 160 meter balun with a mix 43 1.4 inch toroid, which will be good for 100 watts. We push the button once we've got this 3 pieces of information in, and it will tell us 1 turn. I'm sorry. Let's back up here. Up here. Yeah. It was anyway. All right. It'll tell you the number of turns. I forget what it turned out to be. Anyway. Okay. Now you might say, Oh yeah, here we go. I'm sorry, I got ahead of myself. So I put in the, I skipped ahead in my thinking here. Here's the calculator. We've put in the mix 43. We pulled the arrow down and we picked out 43. We've pulled the arrow down and we picked out an FT 140 toroid, FT 140 43 toroid, which we can order from Ferrite Corporation. That's good for 100 watts in FT 140. On 160 meters, we need 17 microhenries. And we put that in the calculator. Then we push the button and voila, it said 4 turns. That's what we need on that toroid to give us the perfect amount of choking on the toroid. So let's build one. By the way, get this out of the way. In the January-February 2023 issue of the magazine for newcomers that the ARRL publishes, called On the Air, this particular little balun, which I've used as an example here, was shown in great detail. And here's a picture of it. It's in a little box, nice little box, commonly available project box with an SO239 connector on it, and three stainless steel eye bolts there that you can mount in the box. One there on the left for hanging, and 2 to connect the wire to make a wire dipole with. And there's the 240 FT 240 mix 43 toroid there in the middle, and the 4 turns that the calculator showed us to use. What have I used for wire? Well, I've used lamp cord, 2-wire zip cord. It's almost perfectly 50 ohm twin lead. You'd be surprised. Lamp cord, or also speaker wire, common speaker wire that you buy, is almost perfect 50 ohm twin lead. So it makes good wire to use to wind toroids with, because it is pretty much 50 ohm coax, almost 50 ohm twin lead. So that's what I used to build this balun with. It works very excellent. You can see it comes in from the SO239, which hooks to your transmitter or to your antenna, and then it goes out to the two wires there on the end. If you use this balun at your shack, you might use two connectors, two SO239 connectors instead of the eye bolts. But you can easily see how to do this. But that's the way to make the toroid, make the balun, make the whole balun. Now, one of my readers who saw this presentation, and this is sort of an extra, this is sort of an FYI for you as well. When he saw this, he said, "That's neat. I want to make one of these," and he wanted to make a balun for VHF. So he got himself a 1.4-inch toroid for 100 watts, an FT 140 mix 61, and that's a picture of it there. And he did the whole thing, and the little calculator said that he should put 6 turns on it, because for that particular frequency we wanted 6 turns, and that's what the calculator showed him, 6 turns. And there's the balun that he built using this. The reason I'm showing it to you, though, is not so much just to show you how to build the balun, although that's a nice example of building a balun. And by the way, you're concerned about the anyway. Notice that notice the box that it's built in. What does that look like? Doesn't that look like a typical 4-inch outdoor conduit box that you can buy at the local hardware store? Of course it does, but it's a lot smaller, isn't it? It's the same waterproof conduit box that you can buy down at your local hardware store, except it's much, much smaller. I said, I wrote back to Joe. I said, "Joe, where did you get that little box?" He said, "It's easy. You can get them in all sorts of different sizes. They're not just, the only ones available aren't just 4-inch conduit boxes. They come in all sorts of sizes. And here's the company that you can get them from. It's called Zool Kit. Let me move this out of the way here. Yeah, there we are. It's called Zool Kit, waterproof electronic junction enclosures. So you can get them and you can see them, and they're not outrageously priced. They this little box that he built it in was $7. That's not bad. Excellent little box with a mounting bosses in the bottom, and a nice little waterproof gasket, brass inserts, and they come in all sizes up to some pretty big ones. Here's an 11 by 8.5 or 8.25 by 11.5 inch box. You can put some nice stuff outside. So I thought that was really great. Now, this is a 49-to-1 or a 7-to-1, as I mentioned before. The 7-to-1 is the turns ratio, 49-to-1 impedance balun that I bought off the internet. I just ordered it, and that's the way it came. You only need to be concerned about the smallest winding. That's the one that matters when it comes to the number of turns. So that's the one that hooks to your jack, your antenna. So here's the process all over again here. It's out of the way. You pick a toroid, pick the frequency, and the only thing you need to remember is the 3 mixes. Mix 31 for VHF, UHF, mix 43 or 61 for HF. The size, FT 140 for 100 watts, FT 240 for a full limit. Then you want to calculate the inductance using that simple little formula to give you an AC resistance of 200 ohms. You can use more if you want, but you don't have to. Then you convert the microhenries to turns using the calculator. And that's all you need to do to build yourself a toroid. It's really that easy. No looking in books, no equations, no charts, no nothing, except that simple little equation to convert the microhenries into inductance. And there's the calculator again, the Amadon calculator. And there's the if you want to do ugly balance, there's the calculator to do ugly balance. It works exactly the same way. They use the same principle to build ugly balance, but instead of using ferrite, you use a coil form to wind turns of coax on, and it gives you the coil diameter and so forth. But it works. The process is still the same, and you end up with the number of turns to put on the coil form. Same basic principle. Same 200 ohms of inductance, and that's it. It's really simple to make ferrite balance. And that's it, folks.
Well, thank you very much, John. We're going to start with some questions from Zoom, if that's okay.
Be sure that people get close enough to the mic so I can understand them.
Well, I'm going to read the first one because he put it in the chat.
Okay.
The first one, he's asking about fan dipoles. When you stick all those other extra wires for each of the frequencies on the fan dipoles, do they affect the design of the balun?
I'm sorry, I don't not following. What fan dipole are we talking about?
So, for example, a dipole which would have one length of wire for 80 meters, a pair of wires for 80, a pair of wires for 40.
I know what a fan dipole is, but where does that enter what I said?
Well, he was curious how that affected the design of the balun at all.
Oh, well, if you mean if you use this balun on a fan dipole, is that what he's saying? I presume
Yes.
I presume that. Well, ferrite baluns have a pretty good bandwidth. If you make the balun for the lowest frequency of your fan dipole, it will work for the higher frequencies also. It'll just add more choking, that's all. And usually the ferrite has a broad enough bandwidth of itself work fine for the other bands that are higher in frequency. So when you design the ferrite, the ferrite choke or the balun, design it for the lowest frequency that you have on your fan dipole.
So he's redefining the question as we're chatting here. On slide 9, you had the extra wire on one side of the dipole. And he's really trying to understand why when you do a fan dipole, it isn't just lots of extra wires, I guess is what he's asking.
Well, I only showed that as an illustration I'm not illustrating what a fan dipole does. Yes, a fan dipole, that wasn't an illustration of a fan dipole. That was just an illustration of what would happen if you would hang a stray random piece of wire on to one side of a perfectly balanced dipole to show you that it would unbalance it and change its frequency and so forth. But a fan dipole, all of the dipoles that you're hooking up there are resonant dipoles.
Okay. Any other questions on Zoom? Go ahead and unmute and ask them first.
WA7PXW.
Go ahead, Mark.
Yeah, I was just curious about his explanation of a skin effect. Does it make a difference if you're using woven or braided wire versus solid? I can't vision how this works on a braided coax.
Where is the braid? On the coax or on the wire of the antenna?
On the coax.
The shield is normally braided, I think, John.
Yeah, the shield is braided. Yeah, that's what I'm talking about, the braided shield. The braided shield on the coax.
Yeah, but how does the skin effect work when you got all these little wires running around? That's what I'm trying to understand.
Well, the braided wire, if it's made up of a whole bunch of little wires, as far as the RF is concerned, it looks like a solid piece of metal to the RF, because the distance between the little individual wires is very small compared to the wavelength. So as far as the RF is concerned, the braid looks like a solid piece of metal, like it was just a metal pipe. So
I see. Okay, I was just trying to visualize it, what's going on.
All right, thank you for the question, Mark. Do we have anyone else on Zoom? All right, moving to the in-person meeting. We have a few questions here. John, go ahead.
Two questions. First question is, I noticed although you said that it's better to have a higher impedance, you chose to input 17 for 17.7 for 160. And I was wondering why you didn't input 18 for that. And then the second question is, how is it where in the shack would you attach a balun then to your radio?
I put the baluns on the coaxes external to the shack. So what you're leading out, or you can put it wherever the coax comes out of, your transmitters or comes out of your shack. You can put wherever the coax ends there. That's where I'd put it. Remember, you're just trying to keep the bulk of the shield going to the antenna isolated. And it doesn't matter whether it's exactly at the transmitter, it can be a couple of feet away from it. It doesn't matter that much.
All right, thank you. We got one more question from the audience.
Okay, Ron, KA7RON. Oh, sorry.
Go ahead.
Okay, in the first question, why did you round down rather than rounding up on the microhenry inductance on the example?
17 microhenries?
Yes, the actual calculation was 17.7, but you rounded down.
Oh, maybe I misspoke. I think it was 17, just 17, wasn't it?
I think
If-
your calculator showed 17.7, and he was curious why you didn't round up instead.
Oh, that's probably just an oversight on my part. 17 or 18 microhenries isn't that significant that it would make much difference.
Okay. Now on to Ron's
Yep,
question.
Okay, KA7RON. Two quick questions.
If the calculator said 17.7, probably should have rounded up. I should have rounded up. I'm sorry, that's probably just an oversight.
Okay, so since you mentioned, you said it would work basically the same way with an ugly balun, but would it be the same if just wrapping the coax around the toroid rather than separating it in the box? And then my other question is, for those who don't know, I unless I missed it, you haven't talked about much about why we need to do this in the first place.
I'm not sensing what the question is.
Okay, if I just put a toroid in line in the coax and just wrap the coax itself around it, would that still work instead of putting creating it in a box and
Oh,
and
sure.
wires? Okay,
If the coax you're using is small enough to be wrapped around the toroid, of
Okay.
course you can do
That would-
that. In fact, that's commonly done. In fact, often coax is wrapped around toroids. I just use the zip cord because it wraps easier around the toroid
okay,
than coax does. I mean, for example, if your coax is RG8, you're not going to wrap RG8 around a toroid.
right. Okay, and then you talked about why we're doing that for blocking the signal on the outside of the shield. But why do we need to do that?
Why do we need to block the?
Yeah. Why is that necessary?
Because of because the current, the unisolated shield is going to RF on the outside of your. I'm trying to form my words here. Going back to the antenna, that illustration I showed you of hanging an extra piece of wire on a perfectly balanced dipole. You don't have any idea where that extra piece of wire is going to go, how long it is, whether it's resonant or not, or what direction it's going to be pointed. It might detune the antenna. It might change the SWR. It might change the directivity of the antenna. And you don't want that to happen to the antenna. That's why we want to choke off. We want to disconnect that shield from the antenna at that end. And at the other end, where the receiver exists, we don't want extraneous signals from neighboring transmitters, from power lines and other things. If you've got a shield hanging out there that isn't isolated from your system with chokes at both ends, any kind of junk, any kind of RF junk will be picked up by that shield. And if it's got a pathway into your radio, which it does, because it can come into that intersection at the end of the coax, and it can get into your receiver. So it's an unprotected shield, where it is an unisolated, a system that isn't double isolated, where the shield doesn't connect to anything at either end, is a wide open antenna to pick up junk or to transmit junk, and so it's just asking for trouble.
Okay, thank you very much, Sean, for your presentation and answering the questions. One final check. Anyone on Zoom with a question? Okay, and no one else in the meeting? Okay, Tim, hold on.
Yeah, if these baluns are necessary, particularly at the transmitter end, why doesn't the transmitter just come with one?
I can answer that because they're cheap.
Yeah.
It was a good question.
I
Thank-
suppose it would be nice if they provided one, but
And you know, if you only have one or two antennas into your shack, it's not too bad. But some of you have seen my antenna, and I have 11 coaxes coming into my shack. And so I have a lot of ferrite beads on various things because I had very undesirable consequences. Sometimes on 40 meters, my mouse would quit working, or
Sure.
my keyboard would lock up, or so having these balance both up on the antenna and coming where you come into your shack is very important. And I visited a couple of contest stations where they bought boxes of 200 of the 2.5-inch form balance and used them to wrap all the coaxes. So it's very valid.
I got onto the fact that choking needs to take place at the shack as well as at the antenna. And I got onto the fact that a balun up at the antenna isn't the only isn't the that you won't have shield, won't have common mode current or RF on the shield if you have a balun up at the antenna. That's a myth by a rather bad situation that took place. Good friend of mine, W6OEK, put up an 80-meter dipole, an off-center fed dipole, and he had an RF weather station that he was using in his house, which sent the information from the anemometer and stuff on the roof down to the little display by an RF signal, probably on 300 megahertz or something like that. And as soon as he put this 80-meter off-center fed dipole up, as soon as he transmitted on the RF weather station, it would go crazy. But he had a perfectly good balun up at the 80-meter dipole. Where was it coming from? Where was the interference coming from? The only thing that cured it, the first thing he tried was to put the display unit down in his shack into a sealed bag of RF fabric to keep it to shield it. Didn't work. Still didn't take care of the problem. The only thing that stopped that RF weather station readout from being blown away by that 80-meter dipole up there with a perfectly good balun on it was to put chokes on the 80-meter dipole down at the shack, at the coax down there. Then his RF weather station worked fine. The coax was the common mode current, and the shield current was getting on the line at the shack end, not at the transmitter end. That's what led me to this realization that we don't just need to choke. We don't need to choke just the antenna. We need to choke any place that the coax ends, where there's a source of power, whether it be the antenna or the transmitter. Both of them can put current on the outside of coax.
Okay. Well, see, we talked too long. We got another question. Hold on.
Thank you for your presentation. Question on the wrapping of the toroid. Is there any set of guidelines for the gauge of wire that you would use for wrapping that? In other words, you wouldn't want a 30 gauge wire and try to run legal limit on it.
Well, no, the gauge of the wire needs to have enough ampacity to handle the power that you're putting through it. Obviously, at 100 watts, it doesn't need to be real heavy. I forget, if you work back simple ohms and watts law, you'll find out that I think 14 gauge wire will handle 1,000 watts pretty easily. The information that's in the radio books on that is pretty straightforward. I don't happen to have it in my head. Typically, 14 gauge wire is usually quite sufficient for a full legal limit. It's not terribly critical if you use wire that's too large. But so the zip cord, which I think was 16 gauge wire worked just fine. Or particular, or no, it was 18 gauge zip cord wire worked just fine for 100 water.
Well, I think that's it on the questions, John. John, thank you very, very much for doing this presentation. Excellent speaker, and we appreciate all the information you provided. And I'm going to be busy building that balun for my Delta trap dipole there, or the Delta loop for the 40 meters. Thank
My
you again.
pleasure, and have me back anytime. I'm always generating new material, so keep an eye on w6nbc.com and you'll see new things pop up from time to time. So all the best to you.
Thank you very much.
Thank you, John. That was most enjoyable. And I'm thinking I need some balance. Although my first antenna as a novice, 100 watts, was just a bare wire. I had an insulator, I had a coax. I split it out. I soldered it to one wire on one end and one wire on the other end and strung it up in a tree. And it worked. And I didn't have too much interference, but it was 100 watts on an old Heathkit tube set. And it did some funny things sometimes, but it worked. So don't let it stop you. You know, get on the air anyway. You just, if you run into something, then you know that you can do something about it with the balun. And it's a good idea to have a balun. So they come in all sorts of shapes and sizes too. Those of you that do portable stuff, you like end-fed antennas, and those have an impedance ratio. They usually have a balun at the one end. And I saw a cute little one online. It looked like a little spark plug. And it was a little spark plug was the balun, and they just had it built on and you connect the antenna to one end and you connect the coax to the other end, and there's your balun. Yeah. All kinds of different designs, you know, and sometimes it's just coax, like I said, wound through a toroid or wound around a piece of PVC pipe. That'll do it. But the ferrite is nice because it concentrates it. You can get the ugly balun you saw was big to get the same effect as a little 2x2 box, you know, so easier to carry around and mount and whatever. Okay. Now it's time for a little bit of business discussion here. The club has elections coming up, and they will be, you'll hear more information, but just to know that the elections will happen sometime end of the year before the January meeting, and they'll be conducted online. You'll be hearing more about it. We'll send out announcements and things. And you have to have your dues paid up to be eligible to vote. So that's the big thing. Every year we have 6 directors for the club, and every year 3 of them get reelected or new ones, replacements elected. And also we have a vote for a vice president. Typical sequence is the vice president one year becomes a president the next year, but at the January meeting we certify the votes, and that's the business meeting. And to vote at that meeting and to vote in the election, you have to be paid up member. So take care of that business. And as such, we are actively soliciting anybody that's interested in helping out the club. The job descriptions for the various directors and VP duties are on the website. It sounds pretty daunting, and but it's not. It's not as difficult. I mean, I was only a member for a couple of years when I kind of got drafted to VP last year, because we had, well, between the pandemic and we had some issues. Somebody that was nominated and voted in for president couldn't accept it after he was elected. So the new VP, poof, he's the president. and we were kind of short, and but really think about it, because it really helps the club. We need people to participate, and it's not it's a learning curve, but it's not a terrible thing. I know the big thing for some people is standing up here talking in front of people. Well, that's my big qualification, I guess. I'm not shy. I've embarrassed myself in front of people so often. It bothers me some, but I get over it. And so, but that's not a big requirement for a director. If you don't know who the directors are, they're listed on the website, but they'll talk some at the club, but they don't have to do that. So if public speaking is an issue, go for a director spot.
Why don't we have all the directors stand up that are here, just so that everybody sees who they are? Ron, come on, Marilyn, Tim, Rick, why aren't you standing up? Oh, okay.
Yeah, Rick Aragon is
Okay,
the other
yeah,
director. He's not here.
And he's the one that's in the hospital. But feel free to ask any of these people about what they do as a director. It's really not too bad.
Yeah, you attend a board meeting once a month, and they're usually not too bad in my estimation, but that's because I'm running them this year. It took me a while to figure out how to, agenda, keep it moving, and okay. Well, under 3. Hey, I hit 1 a couple times, but we get a lot of business done, and it's required. The directors have the vote. I'm the president. I don't vote on things at the meetings. I happen to be the chairman of the board too. That's another side position I got. But the directors are the ones that decide the club policies, decide the funding. They have the power, and they do the voting. And each director has a certain area. There's a operating director, technical director, general director. And look on the website. The job and if you think seriously, if you think there's any way you could contribute, it's not that onerous. Half the time, half the directors for a director's report say, well, I have nothing to report this month, or some little thing. So the club really could use more people to help. And it's, it's not a huge, it takes a little bit of time, but a lot of it is how much time you want to put into it. And so it's not really that onerous at all. So I'd encourage people that they're interested at all in helping with the club on a more regular basis. And as a director, you don't even have to attend the meetings. I mean, it's nice, but and most of them do. So yeah. And you're hired for 2 years. So like this year, 3 directors are going to be changed out. Next year, the other 3 will be changed out. And you can swap jobs in between if you find that you'd rather be technical than liaison. Okay, you talk to the liaison. You can, that's worked out. You're not signed on to absolutely to one position for the whole 2 years. If there's an option when the new directors come in, they kind of work out, okay, who's going to do what position. And it's a good group. It's a good way to do business, and it works. So like I said, think about it, please, and contact any officer if you're interested, and let us know. And I'm hoping that we'll have, well, it'll be published. We'd like to have some names and have some idea by the Christmas meeting, so we can say these people are the people that we're looking at, and then the ballots will come out and you'll vote. And then in January, we certify the election. We have actually the membership vote and say, okay, we accept the new, So,
and just to clarify a couple of things, the reason that you have to have your dues paid before Christmas is that we have to take a list to put it into the online mailing, and then we have to close the actual online election before the business meeting, at least a day or so before the business meeting. So you basically have about a 2-week period to do the electronic voting. You'll receive an email with a link that you go and do the voting. It's all very confidential. We do have a couple people each year that don't have any email, and if they reach out to us, we can make special accommodations for them as well. But we'd rather do it all electronically. That gives the people who are not only here, but other members of the club a voice in who gets elected.
Yeah, and that hits up all the snowbirds, that move down south for the winter, they get to vote too. So anyway, thank you. And think about it, please. And we look forward to you all participating. Okay. As we said before, the Veterans Day Parade is coming. Those of you who volunteered, I know Bern sent out notices to everyone, the communication plan with the 3 frequencies, the primary, secondary, and simplex. And please test your radios before, program them, test them, and make sure that, you always have somebody that, oh, I can't hear them and they need some help. We help, but please test them. And it's likely to be wet and probably pretty cool, so dress accordingly. And if you're participating, you need a vest. We encourage, well, we want you to have a vest, and they're for sale on the back table there. There's also, well, that's all signed up, and we're all signed up for this one. And in the vest, there is a nice pocket that, well, actually, no, I have a jacket that has a pocket, but you need to think about protecting your radio from the rain. It helps to have some kind of an earpiece, or, a speaker mic will work, but it's nice to have an earpiece or a headphone. I have a single headphone with a speaker on it that works real well. But, just typical stuff. And those of you that volunteered, you should have all the information. And for the rest of you, encourage you to come out and watch the parade. And after the parade, there's a CMAC event at Pearson Air Park that will be open. You can go down there, and they usually have hot dogs and some freebies, swag, and a bunch of people demonstrating stuff, talking about stuff. And that's pretty cool too. So, but it's a good parade. So highly encourage everyone to come out to it. Walk and knock. Is that the next one? I'm out of order here. Walk and knock is coming up. I seem to be, where am I? Ah. Okay, Walk and Knock. Those of you that don't know, Clark County it's one of the largest single day food drives in the country. It's called Walk and Knock. And this year it's on December 7th, Saturday. We're going back to the old Walk and Knock, where they'll pass out a paper bag to just about everybody in the county, in the mail usually. And they ask you to just put some food donation in it, put it on your porch. And then comes the walk part. And they'll often knock on doors too. That's where it comes from. But we canvass the whole county, send groups out, and it's all kinds of groups, cheerleader clubs, band members, scouts, families, and they organize them. They meet at certain areas, and they just cover the whole county and pick up the food and take it to a center where they get loaded on trucks and taken to the food bank. And our job is to provide the communications for that. So when they meet first in the morning, there's a radio operator at each meeting location, and they check to make sure that everybody is there and that everybody, and they get a count of how many people are in each group and how many drivers and how many walkers and from what area. And then we go to the collection centers and call for when a truck is full, they need another truck, they need more boxes. Just the logistics of covering the whole county is pretty big. So it's a good time though. And for those of you that sign up, there's a sign up sheet at the back table, or Reese Carpenter and Barbara Yassen are actually running it. But if you go see Phil at the back table, he's got a sign up sheet there. And it is a good time. Yes. Okay. 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 Thank you, Dave. Yeah. But yeah, you get a free breakfast too. And it's a good breakfast. You got to get there pretty early though, because they do get started Anyway, we encourage everybody to sign up for that. They need quite a few people. And you'll be hearing more about it, but December 7th, so it's before the next meeting. So think about it, and you'll get the weekly emails, and ask Phil back there or Dave more about it, I guess. Please participate. I don't know where they're at right now as far as how many volunteers. I know a lot of people have volunteered, but you'll be hearing more about it. Anyway, I think I covered that. Let's see. Yeah, it says here on the announcement, they need enough radio operators to cover 32 areas and 10 sectors. That's quite a few people. They help, but there's people at the sectors to start with too. And they just add more. And yeah. Anyway, and you might get sent other places. If your area is kind of light and they need more help over there, they'll ask you to go to another school or meeting place where they're loading. So anyway, thank you very much. Please participate. Now, the banquet is coming up, and that is next February. That is the awards banquet. It's a catered banquet, and it's when we actually install the new officers and directors. And that's when my term will end, and Dave will become the president. And we present a lot of awards. We have a lot of awards. Once again, if you go online, there's a page that says awards, and you'll see some of the awards that are given out. And it's always a good meal. The caterer is real good, and we're doing that again. And I'm forming a committee of volunteers to help plan and organize it. You know, somebody to pick up the cake. We've got somebody to work with the caterer, but anybody that would like to help in any way, even if it's a setup or getting a hold of the flower decorations for the tables or whatever, please talk to any officer or talk to me, and we'll be sending out an announcement about having meetings starting here pretty soon, so we can touch base and make sure we're on track for it, because it does take a bit of planning. There's a whole, and if you participate in any event during the year, field day, walk and knock, parades, Tazewell parade, you get a certificate of participation listing everything you've done for the club. So that's another thing. Anyway, contact me if you'd like to help out with the committee in any way. Thank you. And then the Christmas party. Yeah, this is a party club. Friday, December 13th. Feel free to dress up if you feel like it. It'll be decorated here. There'll be live music, like it says, live music, caroling, cake, raffle prizes. It's not a meal, but there'll be snacks and cake and stuff and punch and whatever to drink. So it's always a fun time too. And there's lots of raffle prizes. You get a good chance of taking home something nice. Encourage you all to come. That's our next meeting too. So that's next month. Okay, Toby, here he is, talking about Toys for Tots.
Thanks, Dave. Can I ask that all United States Marines please stand for a moment? Well, at least two of you. There's three of us. Sunday, November 10th, this Sunday is our 249th birthday. We don't look a day over 240 years, do we, Dave? Yeah. That's a fact. My name is Toby Claremont, H7FR. I am the Senior Vice Commandant for the Marine Corps League here in Southwest Washington. One of my responsibilities is to coordinate Toys for Tots in the Vancouver, Skamania, Cowlitz County areas. And what has become, I guess, a new tradition with the club is to contribute new unwrapped toys to the Toys for Tots campaign. And what we do is we take those toys and we sort them by gender, there are two, and age. And we distributed them to social agencies, to children who do not have Christmas. You know, a lot of kids are having a hard time. It's a real deal. And the club is really fortunate to be able to contribute to this effort. So at the Christmas party, if you will bring a new unwrapped gift, we will put it into Toys for Tots in the name of the club. One word of caution. I'll be putting a box out here. I don't think, maybe Julie's put it out there already. You'll see a Toys for Tots donation box out there. Do not put your toy in there because then it won't be credited to the club. So bring it straight into the party. You'll see me on the form, and I'll accept your gift on behalf of the Marine Corps. And Dave is our president. Will be, here you go. And then the following day, I'll take them down to Swan Island where we have a Marine Corps detachment down there. And that's where we process all these toys for Southwest Washington and Northern Ireland, Oregon. So any questions? It's a good thing. Now, there are a lot of toy drives out there. And I can tell you, not without, I don't know, saying anything nasty about any of them, not all of them go to the right people. And when I would say that, sometimes they're distributed kind of hastily. And what we make sure is that they get to kids that don't have Christmas, don't have toys for Christmas. We don't want anyone left out. It's a very successful effort. All of you in this room have probably heard about Toys for Tots your entire life. That's how long it's been going on, like 70 years. We go out and do functions in dress blues, and we accept them from, you know, the whole deal. So thank you, Dave, for the moment. And we'll see you on at the Christmas party with new unwrapped Christmas gifts. Don't put them in the bin out in front. Thank you.
Thank you, Toby. We applaud you Marines for doing this. Hoorah. Okay, now for those of you that are interested in DX, we have a member who is going on a DXpedition. He's going to go out there and give some context to people. Al.
Good evening, everybody. I will be leaving next Thursday for the location there that has 2 circles on it with my friend Bob, W7YAQ. And we'll be on for, what's that say, 13 days on HF bands and 6 meters. We'll be on side bands, CW and FT8. And after our trip to Wallis Island, we'll be in Fiji for 3 days and then head home. So look for us. We'll be very active. Fox Whiskey 7 AA and 3 Delta 2 November Bravo. Okay, we'll be happy to work as many club members as possible.
And they do a great job. They're very workable. So get on and listen.
Thank you, Alan. I hope you have a good trip. And we look forward to a little presentation afterwards. You always have some adventures, and we're glad to share them with you.
Hold on a minute, Dave. Gary, you said you're not seeing the slides on the Zoom? Hold on, let me get it fixed. Okay, Gary, how's it looking now? Are we getting the right slides?
Yep, we're with you now. Thanks.
Thank you for the heads up, Gary.
Yeah, we don't want to leave anybody out. So next up, we were going to talk about the field day results that came in, Dave.
So
happy to see.
for those of you who are ARRL members, the QST has come out and the field day results for 2024 are there. And I thought we'd just mention it very quickly. In 2023, we had a very, very good year. They had 168 entries in 2023, and we were 18th out of 163. However, last year, we really kicked butt. 2024, 183 entries in that class of 4 alpha, and we were 10. So we almost doubled our position or better, based that there were more things. Now, you can see the list of people who are out in front of us. You'll notice there's no K7LE, the Mike and Key Club up there. They do an outstanding job. This year they were 6 alpha instead of 4 alpha. That's why they're not up there ahead of us. They normally do about 5,500 QSOs as well. So we have a ways to go to catch them, but we did a really, really good job last year. And I just wanted to say thank you to everyone who was at Field Day.
And we thank you for all the effort put into setting it up. You want to talk about operating events, or you want me to?
Actually, I was going to make Tim do it, but he's not here tonight. ARRL sweepstakes. That's November the 16th and 18th. It's a 30-hour contest. The object is to work all the different states and Canadian the Canadian provinces. There's 85. It's probably the most complicated contest exchange of any radio contest that's out there. Everybody's nodding their head. So for example, my exchange to someone might be 0051. You're my 51st contact. I'm an Alpha, Whiskey Zulu 8 Tango, check of 89, and I'm in Western Washington. So I would have to say all that every time I made a contact with someone. But it is a lot of fun. So if you want to do worked all states, this is the contest to do it in. And there will be lots and lots of people on. And then for those of you who actually know how to do CW, the CQ Worldwide contest is not Thanksgiving weekend. Once every 5 years, it's not Thanksgiving weekend. So all the people that do the CW contest have to make a choice, family harmony or content. And sometimes they compromise and it's neither harmony or good contest. But so that's November 23rd and 24th. And this one is a lot easier. Whiskey Zulu 8 Tango 03. But they do cut numbers, which is something else. So it would be A3. So, but it's a CW contest. There will be people going really fast and people going nice and slow. So even if you can't do well with CW, you can sit and listen long enough to somebody, you can actually get it figured out, and it's well worth getting on at least and giving it a try. So CW is alive and well in ham radio. So just put that in there.
Thank you, Dave. Yeah. So now, John, before we get to the 50-50, John had a request he wanted to make of the club real quick.
Okay, because that's right, the video. So I have a friend that's giving his. So I am looking for a few able-bodied people. We have a flatbed trailer that Tim is going to help with. And I've got about 4 people so far, but it'd be nice if I could get maybe a couple more. So if you'd contact me, John Bachhoffner, KJ7 AOL, I'd appreciate it. And then the second item is, what year birthday is this of yours, David? I think it's important that we sing happy birthday to our honorable president.
Happy birthday, dear Dave. Happy birthday to you. Nice harmony.
You got me, John. I thought you just wanted to make an announcement. Okay, I guess I don't need to hide it. I'm going to be 71 this year, so I'm not as old as some. You know, I'm a spring chicken compared to some, but you know. Okay, so that's oh yeah, social opportunities. Sorry, I flipped it over the wrong way. The usual weekly breakfast, we highly encourage anybody to come. It's right over here on 136, across from the Furstenberg Library, just north of Mill Plain. Kitchen Table Cafe. Come one, come all. It's a good time. We got our own little corner, and they take good care of us. Been doing it for how long, Dave? 20 years or something? since way before I got here. And, yeah. Okay. Yeah, anyway, it's just a coffee shop breakfast, but it's always there's always a good discussion about something and a story about something, and it's a fun time, and that's every week. 8 a.m. is when she starts taking orders, and then we do a monthly lunch, and Tim McLaren organizes that, and it's the third Friday, so next Friday. At 1 p.m. So we missed the lunch rush, you know. This time it's going to be at the Margarita Factory in Battleground. It's just off of Main Street, at the corner of Parkway and Main Street in Battleground, on the north side of the street there, if I remember right. And you're all invited. And once you've been a club member for a while, you realize how much this club likes to eat and socialize. So I think that's what we do. One of the best things we do. So come and participate. It'll be a good time. So, yes.
Okay, hold on. I need someone's help. This was left at the picnic, the club picnic, and it's been tripped over at least a dozen times in my walkway and garage. Was anyone willing to claim this? At this point in time, that would be great. All right. No one's claiming it. All right. Wendy, we have a new cold container at home. So, all right. James.
Yeah.
Okay.
Any other announcements we need?
Okay,
Steve.
Hold on.
Oh. This is WB70SV, and a lot of you know I used to work at Larson Antennas, designing antennas. And in the time that we were occupying the facility on Northeast 50th Avenue, we outgrew it. So Jim bought the land just south of SCH America and put up a very large manufacturing and shipping facility. He also installed outside in the back of the building an antenna range with a turntable that rotated at 1 RPM. And he bought an old body of a four-door Ford, I believe it was, sedan, had all the seats and inline headliners and everything stripped out. And we mounted antenna mounts all over this thing and did surveys to find out what kind of gain and direction signals that was coming off of antennas. And 50 feet away from that, he put in a fiberglass stanchion 12 feet high and had several vertical dipole antennas to transmit signals and to receive signals off of this contraption in the field. And we used a HP 8753 network analyzer with S parameter test set to do the monitoring and the analyzing of the signals. So what I've done, I've made some copies of antenna locations on this vehicle, and you're all welcome to have a copy of it if you're going to put a mobile antenna in your car. If you use a mag mount to get best conductivity between the body of the car and the base of the antenna, use a Larson mag mount. It's got a large metal plate for capacitive coupling into the body of the car. So I'll put these on the back on a side table, and you can help yourself to them. And if you have any friends, you can grab a copy for them also. So any questions? Okay, thank you.
All right, Steve, you had your hand up about something.
If anybody is interested in sharpening their CW skills for CQ Worldwide CW or similar event, good suggestions would be slow speed test or medium speed test. Details are available on the contesting.com website.
All right. All right, I think we're up to James.
I think so. I think so. Anyway, time for the 50-50. And then after we're done with the drawing, it's time to say goodnight. And
We have a problem. There are still books on this table.
Yeah, grab a book.
What did you guys not understand about they have to all be gone? No one goes out that door, so all those books are gone.
You've got a fireplace.
Okay, all right, good evening, KE7ZAC. One quick note, as members of the club, if you want to get involved with the club and you want to contribute, look at running for an office. That way you're involved. You help keep the club going. This is a great club. We'll be 100 years old here in a few years too. The club will. I won't, but the club will. And one of the plank owners is Dave Femister. One of the plank owners, and you got Phil Yassen back there. So a lot of old timers here. We're gonna do 50-50 a little different. Right? The first thing we're gonna do is give away some items, and we do the money last. So whoever wins one of these items, ticket goes back in the bucket for the chance for the money. All right, keep it simple. 50-50 is where we take half the money, give it to all the participants that can buy a ticket, and the other half goes to the what do you call it, gift fund for prizes, whatever later. Okay, first thing is a Yesu hat. If you are not a Yesu fan, don't take it. Let somebody else do it. We'll throw another number. I have over here, and the first number. Pull one up right there, please. Mr. Smith with the sticky fingers. Sticky Ricky. Okay, last four numbers is 0080. 0080 for a Yesu hat. All right, come on up, my friend. See your number there? Okay, go ahead. We'll put that back in there. Yeah, put it up. Oh, sorry. Next, Yesu hat 0085. 0085. Nobody wants it. 0111. 0111. Stan, Yesu hat? Yes. 0111. 0111. All right, fantastic. Okay, fantastic. The next item is a hand mixer. No portable hand mixer. No. Good stuff, food. Hand mixer, and the number is 0100. 0100. All right, fantastic. You making cookies tonight? Okay. No. And we have a throw. This is a lightweight throw to keep you warm in the winter while you're sitting watching TV. Drink a little bit of adult beverage. 9986. 9986. 9986. 0103. 0103. 0103. How about 0115? 0115. 0115. Nobody wants the blanket. Oh. You got to move fast, bud. The glaucoma's kicking in. I didn't see you. All right, Steve, there you go. Congratulations. Okay, we have coffee cup, ARRL coffee cup. Spectrum Fund, Defense Fund 2024. 2024. Number 9991. 91. 9991. 9991 for a coffee cup. Right there for Michael Brand. My friend. All right, there you go, brother. You got to take the box too. All right, let's put all these back in there, Mr. Smith. And tonight we have a total of $72. $72 tonight for the lucky winner of the 50-50. And that number is nice too. 0123 0123. Judith, all right. $72. Okay, make sure you renew your membership before you leave. That's all I have. No more money, no more prizes, no more toys. Have a great weekend.
Thank you all for coming and drive safe on the way home, and please help pick up the chairs. Good night.